Wow, I am driving this car. Oh no! I am in the blind spot of a truck!
Don't you mean the area of limited visibility?
Oh! Ah! Oh my god, look at the damage to my car! If only that semi-truck had a lane-changing collision avoidance system!
I'm Brian Gorman from Engineering Design Team 14-6, along with Lamont Lee, Tim Abbott, and Caleb Liu. And we are working with PACCAR on a lane change collision avoidance system. Our mentoring faculty member is Kevin Leibarger, and our liaison engineer is Mark Frederickson from PACCAR.
Hello, my name is Tim Abbott of Team 14.6. We are working for PACCAR, which is a manufacturer company of trucks. They range in all sizes from like light, medium, heavy duty trucks, as well as on freeway and off freeway trucks. So we are creating a lane changing collision avoidance system for PACCAR via a network of sensors around the truck. They can only be placed on the cab, and we need to alert the driver when they start making motions to change lanes. If there's any object in the other lane that they're trying to change into, we alert the driver of the collision.
Hi there! You've already probably met Brian and Tim. Now, this is Lamont talking for 14.6. Anyways, as a greater description about what we're doing, this is a general diagram of our system. So here, we're going to have a CAN bus which is already installed in all trucks. And the CAN bus has the ability to take in information from like the transmission, the engine, the cab, and the ABS, the braking system, and pretty much store it and use it for other things. But our project is going to be able to utilize the CAN bus. We have access to all this information, and that will go into our system. Right now, we don't know if we're going to use a laptop for computation or a FES board, or many other kind of boards like a DSP board or something to that degree. What this board will then do is it's going to check to see if there's a vehicle or an object in the area of limited visibility, either on the driver's side or the passenger side of the vehicle. Once it's done that, it's going to take that information, send it to our little FES Cobra board or our DSP board or system board or whatever we're doing our computation with, and it will then tell the driver through the CAN bus that there's a vehicle there. This will then eventually come up to a display and alert the driver.
Right now, we have to research possible solutions and what has already been done, and we're also researching what has already been done in the automotive industry. We looked into 4 specific sensors, one being ultrasonic sensors. They are cheap, they work well at short distances, but because the signal travels through air at high speeds, such as on a freeway, the resolution is going to be very poor, so it's not viable for our situation. And then another option we've been looking at is radar sensors. They're great, they work at long distances and they're reliable, but they only get like a planar view of everything. And what's nice about them is they can determine velocity and distance. But the only problem that we found is that commercial radars are not readily available. The highest resolution sensor we've been looking at right now is LiDAR sensors. They can get a physical readout of like objects up to a really high distance. The only problem is that they're way out of our budget. And then the last sensor we've been looking at is the camera sensor. It's got a low price, it's computationally inexpensive, and it's most valuable for our project.
Hey, I'm Caleb. A huge part of our senior design project is going to be software engineering. We have to develop on a processing board, so we have to be able to communicate with the sensors and bring in the data, and then we have to be able to interpret and analyze that data in order to determine whether or not a collision may or may not happen. So this is going to involve us researching and looking at different algorithms that we then have to implement. Currently we are looking at doing this in Visual Studio in C# because this is how PACCAR currently works with their CAN bus, and by doing this, we'd be able to both send and gather information with the current system more easily than if we were to use maybe like C. But unfortunately, to do this, we have to first decide on which solution we're going to use, and we are going to spend the first quarter doing so, doing all the research, and it isn't until second quarter that we're actually going to start implementing and start working with the actual sensors and with the actual code. So I guess we don't have much for you right now, but we're going to have more in the future, so hope you are stay interested, and we promise that we'll bring you more good stuff. Thanks.
I think Caleb Blue is a great team manager. He's really getting the most out of all our team members.
Recording?
And a truck is a large vehicle, and